Hello, hi student. How are you? Fine. Good afternoon. So today we are going to discuss about the topic by the name of density of state function. Okay. So what is this density of state function? So until till now we have completed about effective mass. Okay. We have seen the effective mass of electron in case of conduction band, effective mass of electron in valence band. Yes, where we have found that the effective mass of electron in case of in conduction band, that is positive, and the effective mass of electron in valence band, that is negative. Okay, and in the same case in valence band we have seen that the effective mass of hole is positive. Yes, so up to this, so far we have done all those things: band, energy band formation, energy band theory, and effective mass, all those things, and about atom we have completed all the lecture up to this. Okay, so now we will start about what density of state function. See, density density of state function, density of state. Yes, density of state function. What? Density of state function. Okay, so this is our topic for today: density of state function. See this. So what do you mean by density of state function? What is the meaning of this density of state function? Okay, density means something, density of state. Yes, density of state function. Yes, density of state function. If you see here, density of what? Density of state. Which state? Which state? These are quantum state. What? Quantum state. See, these are what? These are nothing but this is a density of what? Density of what? Density of state. Which state? Quantum state. Okay, so quantum state, density of quantum state. Okay, so density of quantum state, or you can say, or density of energy state. Yes, energy, density of energy state. Yes, these are what? Density of what? Density of quantum state. Yes, density of quantum state or density of energy state. Yes, density of energy state. Where where we want to find this density of energy state or quantum state? Inside what? Inside a semiconductor. Yes, inside what? Inside semiconductor. Inside semiconductor. Yes or no? Semiconductor. Inside the semiconductor. Yes, inside semiconductor where? Inside the semiconductor where? In conduction band and valence band. Okay, so in conduction band, in conduction band, in conduction band and valence band. Yes, valence band. Okay, so here we want to find what? The density of state. Density of state means what? Density of quantum state or energy state. Inside what? Inside semiconductor. Inside semiconductor where? Inside the conduction and valence band. Inside the conduction and valence band. Energy state. Now what are those density of state? It means what are those density of quantum state or density of energy state? What are these quantum state or energy state? Okay, so now we will see. Okay, so this is what this is about. This is the brief explanation of what density of state function. This is what density of quantum state or energy state inside what? Inside semiconductor. Inside semiconductor where? Inside conduction band and valence band. Okay, by this what we want to find exactly? So if we are able to calculate this density of state with, okay, so here what we want to find in conduction band and in valence band, what? Density of state, density of state. Yes, density of state means what? Density of quantum state. Yes, density of quantum state, density of quantum state in what? Valence band and in conduction band. Okay, so by this what we are able to find? We are able to find what? Number of electron and number of hole. What? Concentration. Okay, so number of electron and number of hole concentration. If we are able to define this density of state function inside conduction band and valence band, then we are able to calculate what the concentration of electron and hole. Okay, in electron and hole. Now see, now what exactly we want. Okay, what is our ultimate goal here? Our ultimate goal in electronic device is what? As we have seen that our ultimate goal in in electronic device and circuit is that we want to exactly what we want to exactly determine what we want to exactly determine the electrical characteristic of semiconductor device. Okay, let us say this is my semiconductor device. Yes, so let us say this is my what? This is my semiconductor. This is my semiconductor device. Yes, this is my semiconductor device. Okay, so through this, what the current that is passing through this device is what? I current. And voltage across semiconductor device is what? V. Okay, so our ultimate goal is what? Our ultimate goal in electronic device and circuit is what? To determine what? To determine the electrical characteristic of semiconductor device. Okay, so electrical characteristic in the sense that we want to determine what? Current versus voltage. Current versus voltage characteristic. Okay, so we want to determine this characteristic. Okay, so our main target or our ultimate goal here is what? Here is to determine the current and voltage. Means what? Current versus voltage characteristic. Yes or no? Current versus voltage characteristic. Yes. So this is what? The current versus voltage characteristic. So we wish to describe what? To describe the characteristic of this current versus voltage. Current versus voltage. So therefore this is what? Current. What is that current? Current is nothing more than that of what? Flow of charge carrying. Yes or no? The current is nothing more than that of flow of charge carrying. Yes, flow of charge carrier in the sense of what? The flow of electron or flow of hole. In case of semiconductor, if you see in case of conductor, there is only flow of what? Electron. Okay, flow of charge carrier. Flow of charge carrier in case of conductor is what? Only electron. Only one type of charge carrier. Okay. If you see in case of semiconductor, there the current is what? Current is nothing more than that of flow of charge carrier. Yes, the flow of charge carrier. Then this flow of charge carrier in case of semiconductor is due to what? Due to both electron and hole. Yes or no? Due to both electron and hole. So this is what? Current. Yes, current due to what? Electron and hole. Inside what? In semiconductor. Okay, it is different than that of what? Conductor. Okay, so now here our ultimate goal is what? To determine current versus voltage characteristic. Okay, so this is what? Current that is passing through what? This device. Okay, so this is what? Voltage across the device. Yes, so this is what? Current nothing more than that of what? Electron, flow of charge carrier. Yes, so therefore what is needed here? What is the important step in this conduction process? Yes, what is the important step in conduction process? This is nothing but to determine the number of electron and hole. Okay, so I am saying here important step. What? Important step step in conduction band, in conduction process, in conduction process. Yes, in conduction process. What is the important step in this conduction process? What is important step? To determine the what? Determine to determine electron and hole concentration. Yes or no? To determine the electron and hole concentration. This is our what? This is the important step where in conduction process. To determine what? Electron and hole. Yes, electron and hole concentration. Yes, what are those electron and hole? These are itself a charge carrier. Okay, so combination of this is nothing but the charge carrier. Yes, charge carrier. So therefore we want to determine what? We want to determine. So therefore here we want what? We want to determine what? We want to determine electron. We want to determine what? Number of charge carrier. Yes, number of charge carrier, or you can say carrier concentration. Number of charge. We want to determine the carrier. Yes, we want to determine the carrier concentration. Carrier concentration. Yes, we want to determine here carrier concentration which contribute in the conduction process. Yes, which contribute, which which contribute, which contribute, which contribute in conduction process. Conduction process. Yes or no? Conduction process. So therefore, this is current for current. What is needed? What is needed to determine the number of electron and hole? Okay. So these are to determine the electron and hole. This is the important step in the conduction process. Okay. So for that, these are nothing but charge carrier. Okay. So therefore, to determine the charge carrier concentration. Okay, which contribute in the conduction process. Which contribute in the conduction process. Now, if you see here, these charge carrier, these charge carrier, these charge carrier are the function of what? These charge carrier are the function of energy. What? Function of energy. If we see here the charge carrier. Now these charge carrier, charge carrier. Yes, these charge carrier either electron and hole. Okay, so this is either electron or hole. These charge carrier are the function of what? Function are the function of what? Energy. Yes, energy. See here, this is what charge carrier. Charge carrier. Number of charge carrier. Okay, that can be electron or it can be what? Hole. So these are what? Function of what? Energy. Function of energy. Okay. So now these are the function of energy level. Yes, energy level or quantum state, or you can say quantum state. Okay. So these are number of charge carrier. This number of charge carrier, to determine this number of charge carrier, which is a function of energy level or which is a function of quantum state. Yes, quantum state. Now, as we know very well, what we know as according to what? According to Pauli exclusion principle. Yes, according to Pauli exclusion principle, which says that only one electron is allowed to occupy the what? Occupy the given any given quantum state. Okay. So what are these energy level? If you see what? During the formation of what? Crystal. Yes, this is what, let us say this is what, during the formation, during the formation of, during the formation of what? Yes or no? So this is what? Energy level. Okay. So this is what? Conduction band. Yes, conduction band, and this is my valence band. Yes, this is my valence band. This is what? Energy band gap. Yes. So now what happens during the formation of crystal? Yes, during the formation of crystal. Yes, crystal, the discrete energy level. Yes, discrete energy level, that is what? This is my atom. Yes, atom. In the outermost shell of this atom, what is there? In the outermost shell of this atom, these are what? There is electron. Yes, this electron has its what? This electron has its what? Its own energy. What? On energy level. Yes, on energy level. So therefore, there is many atom. Yes or no? There is many atom. So this is my electron. Okay. So now see here, each electron has its own energy state. Yes or no? When during the formation of solid, these discrete energy level will get split into what? Split into what? Allowed and forbidden energy band gap. Yes, these are allowed. These are what? Allowed energy band. Yes, these are my allowed energy band, and this is my forbidden energy band gap. Okay, this happen where? This happen approximately where? Approximately interatomic distance. At what distance? Interatomic distance. Okay, so when the atom is coming very close to each other during the formation of solid or crystal, the discrete energy level, they will get split into band of allowed energy and forbidden energy. Yes. Now these are what my, this is my conduction band, this is my valence band. Yes, valence band. Okay. So now these are what? Discrete energy level. Okay, discrete energy level. So these allowed energy band. Okay. As we know very well, each allowed energy band, which is actually made up of what? Which is actually made up of discrete energy level. Okay. So this discrete energy level is nothing but what? This discrete energy level is nothing but it is a density. It is ultimately what? These are the density. These are what? Density of quantum state. Density of quantum state or energy state. Yes, energy state. These are the density of quantum state or energy state. Yes, energy state. So this is only the density of function. What? Density of function. Density of quantum state or energy state, either in conduction band, either in conduction band, or either in valence band. Either in valence band. Okay. So this we want to find. Why we want to find this density of quantum state or energy state? Because what actually we want to determine what number of electrons. Because this is my what current. See here, this is my current. For current, what is needed? Flow of charge carrier. What? Flow of charge carrier. Flow of charge carrier is needed. Like electron or hole. Electron or hole. Yes, electron or hole. So for this electron and hole, to determine this electron and hole, what are these? These are charge carrier. Yes, these are charge carrier. So therefore, to determine the concentration of this charge carrier. Okay. So this charge carrier concentration. Okay. To determine this is a function of what? Energy level. Okay. How many energy level? How many energy level is there? Okay. How many energy state or quantum state is there? That many electrons and hole are present in the conduction band or in valence band. Yes, valence band. Okay. So that's why our main target or our ultimate goal here is to determine what density of quantum state. How many density of state is there? How many quantum state is there? Okay. How many energy state is there? Okay. How many energy state is there? That many electrons and hole are present in either in conduction band and in valence band. Okay. So this is the main purpose of what this density of state function. Why we need the density of state function to density of state function? Why we need? Because actually in electronic device and circuit, our ultimate goal is what? Our ultimate goal is to determine the electrical characteristic of the semiconductor device. Okay. So or in the sense that current and voltage characteristic of semiconductor device, where the electron is nothing more than that of the flow of charge carrier. So this flow of charge carrier is nothing but either electrons and hole. Okay. So therefore, for that we need to determine what the concentration of these electrons and hole. How many number of electrons and hole are there in the conduction process? Okay. So where it is the one of the most important step in the conduction process. For that we want for that when we go for to determine the concentration of the charge carrier, which is further a function of what? Which is a function of energy, which is a function of energy level. Which type of energy level? Those energy level which get split during the formation of what? During the formation of solid. Okay. Into a number of into what? Into the allowed and forbidden energy band gap. So this allowed band is actually made up of what? Number of discrete energy level. Okay. So these are very these are what? Quasi distribution of energy. Okay. So this is what? Density of state function, in the sense density of quantum state or density of